In this chapter, we will discuss about the steam systems in cogeneration and such utility. Knowledge about steams and the behavior and usage is very important when we discuss about plant utilities because steam is used extensively in chemical plant. So what are the usage of steams? You can see here that steam is used for the indirect heating. So steam is basically the source of heat. Direct heating, okay, can also be used. Steam can also be used for the direct heating by just mixing the steam with anything that we want to heat. High pressure steam is used for power generation in the steam turbines. Steam is also used in the vacuum ejectors, flare automation, stripping agent in the separation process, diluent in the reactors, and so on. So there are many other usage of steam. So why that steam is used in so many different applications? These are the features of steams that make it very interesting in chemical process. By using steam, we can generate energy, heat in this case, at one point and then distribute it. So you can imagine that in one of the chemical plant that need a lot of heating, okay, we can have one centralized boiler system that produce the steam that can be used in all processes. Okay, also transferring energy using steam is very convenient because of it is pressurized. It's moved by itself. We just need a piping system. Steam also contain high latent heat. So high latent heat is very important because of not only the quantity of the heat, but also we will be able to heat to provide heat without even changing pressure by by using the latent heat. Also, steam is easy to control the temperature. You can basically play with the pressure. Can be used to drive the mechanical equipment locally, like for example, steam is used to in the turbine. Steam is relatively cheap and it's safe. So those are few of the important features of steams for process heating. To illustrate how the steam, how important is steam in the chemical plant, uh, this figure shows a typical utility systems, okay, in which steams play quite important roles. Steam is generated through the furnace here, so basically we convert the chemical heat from the fuel to become the enthalpy in the steams. It can first be used in this is steam generator. So one of the easiest way to generate electricity is by using steam generator here, and we can generate power. So now by generating power, basically we have electricity also to run the system to provide the electrical power for the pump and other things, for the sensors and other things, generate power. The power can also be sold to another plants or to the publics. Okay, then we use steam for we classify steam depending on the pressure. We have steam at high pressure, medium pressure, and lower pressure. So basically this part is what we call as steam distribution. See how important. And then the steam can go to the process. For example, here we have the process A, the user of the steam, process B, and process C, and in the end some of the steam will condense and then might be cooled down to uh, and then let go as the wastewater, or the condensate of the steam can be recycled back to the boiler. Okay, so by looking into these figures, we can see that there are so many different components in the steam systems. First of all, it is not shown in this graph. The boiler feed water treatment. It is basically to treat feed water that will be used, that will be converted to the steams. The steam boiler itself, in this case, can be represented by this unit. Steam turbine, which is here. We got a steam distribution all of here, and then lastly the steam users. To be able to fundamentally understand how steams can be used in different aspect of chemical plant, have looked into the properties of steams in the steam table, because that will empower you to understand fundamentally of how engineer can actually use the steam to support the operation of the chemical plant.